Hello friends, welcome to my channel. In this video I will cover engineering mathematics Laplace transform. Already first shifting theorem covered, second shifting theorem also covered, then multiplication by t, division by t also covered, then change of scale property. Then in this video I will cover integration and differentiation. Integration of Laplace. So here Laplace transform of f of t, as usual it's f of s. Then Laplace transform of integration of 0 to t f of t dt, it's equal to 1 by s f of s. If it is 2 times integration 0 to t f of t dt, we will get 1 by s square. Like this, L of 0 to t n times f of t dt, you will get 1 by s to the power n f of s. So in example, question is find Laplace of integration 0 to t e to the power minus t divided by t dt. So step by step we will do. Our f of t is 1 minus e to the power minus t. Step 1. First we will do Laplace of 1 minus e to the power minus t. This is Laplace of 1 minus Laplace of e to the power minus t. First shifting theorem we have to apply for e to the power minus t. Here Laplace of 1 is n factorial divided by s to the power n plus 1. n is 0 here. So you will get 1 by s minus 1 by s plus 1. Because here it's minus t, so you will get 1 by s plus 1. Then in second step, we will divide t, Laplace of f of t divided by t. In second video already I discussed this one. If it is division means you have to do the integration. So it's s to infinity f of s. Then put the values of f of s. f of s is this one. This term is our f of s. So it's s to infinity 1 by s divided by 1 by s plus 1 ds. If you do its integration, you will get log s minus log s plus 1. Your limit is lower limit s, upper limit infinity. And if you solve this one, you will get, further if you solve it, s by s plus 1. s by s plus 1, limit you put s to infinity. Then it's infinity by infinity coming, so further you have to simplify it. Log s by divide s 1 plus 1 by s to infinity. Again you will get log 1 minus log 1 by 1 plus 1 by s. Here limit you have to put s to infinity. Then you will get 0 minus log s by s plus 1. So finally you can write s plus 1 by s. This is your answer. Here integration. So again in step 3 you have to do Laplace of 0 to t, here given is 1 minus e to the power t, 1 minus e to the power minus t divided by t dt. You have to find out. It's 1 by s f of s from our formula. Again we got f of s is this one or new f of s. So 1 by s f of s is log 1 plus s divided by s. This is your answer. In next example, Laplace of e to the power minus 3 0 to t integration sin t divided by t dt you have to calculate. So division by 2 and e to the power at term also available. First shifting theorem, then your division by 2 formula also you have to use, then integration formula also you have to use. So in step 1 we know Laplace of f of t, it's equal to f of s. Step 1, Laplace of sin t we will do. Laplace of sin t, it's 1 by, omega is 1 here, so 1 by s square plus 1. In step 1 you will get this one, Laplace of f of t, then divided by, this is f of s up to 1. Then in step 2 you have to divide Laplace of sin t divided by t. It's division, so you have to do the integration. S to infinity f of s is 1 by s square plus 1 ds. It's tan inverse s by 1. So tan inverse s to infinity. Tan inverse s is 5 by 2 minus tan inverse s. You can write it as cot inverse s. So this is your current f of s. This is up to step 1 f of s, and up to step 2 this is current f of s. Then again you have to e to the power 3t. First you have to do the integration, then you have to do fast shifting theorem. And we know 0 to infinity f of t divided by t dt. 0 to infinity f of t dt Laplace is 1 by s f of s, and our f of s, current f of s is cot inverse s. So finally our term is 0 to infinity sin t divided by t dt. Current f of t is this one. Then 1 by s into f of s is cot inverse s. Then in step 4 we will do fast shifting theorem, and we know next from fast shifting theorem we know Laplace of e to the power at f of t equal to f of s minus s. So here in third step we got f of t is our current f of t, it's 0 to infinity sin t divided by t dt, and f of s is 1 by s cot inverse s. So there you will put the fast shifting theorem. So finally, in case of positive a you will get s minus a, but in case of negative a you will get here fs plus a. So here a is minus 3, you will get fs s plus a. So f of s is 1 by s plus will come s plus 3 cot inverse s plus 3. This is your final answer. Then Laplace transform of derivatives, ordinary differential equation. Laplace of f dash, it's equal to s into Laplace of f minus f of 0. And Laplace of f double dash, it's equal to a square L of f minus s into f of 0 minus f dash 0. How you will get this one in this second term? L of f dash is s into L of, we know in first term, this one first, this one second, L of f dash is s into L of f minus f of 0. So here in second term we will put L of f dash is s of L f dash minus f dash 0. So here s of L f dash, it's s a square you will get, or in next term we can write L of f minus f of 0 then minus f dash 0. Here you will get a square into L of f minus s into f of 0 minus f dash 0. And if you take the nth term, Laplace of f of n, s n Laplace of f minus s to the power n minus 1 f of 0 minus s to the power n minus 1 f dash 0, like this up to f to the power n minus 1 0. So I will do some examples so that you will clear in this. Question is, if f of t equal to t sin omega t, find Laplace of f. So f of t is, solution f of t is t sin omega t, then f of 0 we will calculate f of 0 equal to 0, then f dash t will do the derivative sin omega t dt by t 1 plus omega t cos omega t. This is f dash t, and f dash 0 is sin 0, you will get 0, here t is 0, so entire term it will become 0. Then again do the derivative f double dash t equal to 2 omega cos omega t minus omega square t into sin omega t. So from our formula, L of f double dash s into L f dash minus f dash 0, if you go further you will find L of f minus s into f of 0 f dash 0. So here this term is equal to this one. This term is 0, here also this is 0. So a square, again we will write, it's 2 omega, then cos omega t Laplace is s divided by a square plus omega square, then minus omega square into sin omega t. No need to write this one, we have to find this one. So Laplace of f we will write here. So this term you will get, from here you will get Laplace of f equal to Laplace of t sin omega t, sin omega t. So t sin omega t, you can do it. T is multiplied here, so you have to do the differentiation, already discussed in my previous video. So finally after differentiation you will get 2 omega s divided by a square plus omega square whole square. This is your answer. This is little bit lengthy. So if you want to do Laplace of t into sin omega t, we know sin omega t is omega divided by s square plus omega square. T to the power n is 1, so minus 1 to the power n is 1. Single time you have to do the derivative. So if you solve this one, u by v 2s omega divided by s square plus omega square whole square you will get. This is same answer. You have to refer my previous video how to use this t to the power n term and division also. Derivative is lengthy, so rarely they can ask this type of questions. This is the end of this part, integration and derivative. Thank you friends, thank you for watching my video. Thank you.